Hello friends, welcome to our channel Knowledge Amplifier. So already in our previous video we have discussed in detail about the structured way of framing correlated subquery, right? Now in this particular video, let's see one application of it, okay? And what problem I am going to discuss that can be solved in multiple ways. There are some optimized way also present to solve this particular problem. But I want to make you very much comfortable with correlated subquery. As I have told you, it is a very important topic from data engineering or data analysis related interview process. So just we want to apply that particular concept in this particular code and we will try to solve it. Okay. And the problem I have taken from lead code, problem number 608 in SQL, and the title is tree node. Okay. So what it is saying that I am having a table which is having the name tree. Okay. The columns are id and PID. What is id? Id is the primary key column for the table. Okay. And each row of this table contains information about the id of a node and the id of its parent node. Okay, that is basically it is kind of hierarchical data. So if you see this particular example, it will be clear to you. So here you can see the parent node is 1. Then this parent has 2 child 2 and 3. This 2 has 2 child 4 and 5, kind of binary tree. Okay, and this data we can represent in a table like this way, right? So id is basically first column, which is primary key, and then there is PID, that is parent id. So like just for example, the id which is having value 1, that is basically this node. Okay, these don't have any parent, right? So PID is null. Okay, then for id 2, if you see, this particular node has the parent as 1, so the parent id is 1 showing. Then for id 3, as you can see, the parent is 1, so 1 it is showing. For id 4, the parent is 2, so for id 4 parent is showing 2. Okay, for id 5 the parent is 2, that's what it is showing. Okay, I hope it is clear to you how the data is getting represented. Now what we have to do, that is each node in the tree can be one of the three types. Either that can be leaf node, that is the node is from the leaf side, okay, or completely bottom, or that can be root, okay, that is the parent node, and or else that node can be inner node. Okay, neither leaf node nor root node. Okay, like here you can consider 1 is basically root node, 4, 5 and 3 are basically complete child or leaf node, I can say, and 2 is basically inner node, right? That we have to classify. So if you see the output, this is how we should be giving the output. id 1 is root node, 2 is inner node, 3, 4, 5 are leaf. Okay, that's what we have to solve it. Okay, now pause the video and try to solve this particular problem using your approach. Maybe you can try correlated subquery or any other approach and check whether it is working or not. Okay, I am going to discuss this particular concept with correlated subquery. Okay, so what we can do, the approach is very simple in correlated subquery. I will iterate row wise. Okay, and each time, suppose I am in the current row, this one, I will be checking whether this id is present in this particular table as parent id or not. Okay, if any id is present in parent id column, that means that particular id cannot be a leaf node, right? Because leaf cannot be parent. So if any id is present in parent id column, like here you can see id 1 is present in parent id column, right? So 1 cannot be leaf node. That way we can segregate what is leaf node. Okay, and then if any id, listen it very carefully, if any id is present in parent node, either that can be root node or that can be inner node. Okay, now how we can understand root node or inner node? That is, for root node only the parent id is null, because for root node no parent is there, that is the first one, right? But for all other ids which are present in parent id, they will be having parent id non-null. So that way we can understand which are root node, which are basically inner node. Okay, and that way we can classify root node, inner node and leaf node. Okay, so how our program will look like? So now I am jumping to the programming section. You can choose MySQL, MS SQL Server or Oracle, whatever language you are comfortable. So if you recall, what are the steps I have explained in creating correlated subquery? The step 1 is create the inner query with hard-coded value. Okay, for each row, how or what you want to compute, that you need to write first as hard-coded value. Okay, so I can do select count star from tree table maybe suppose you consider any random row, suppose this particular row. So for this row, what we want to see this particular id is present in parent id column or not. So initially we will be creating the inner query with hard coded value. Okay, so select count start from tree where this id is 3 equal to PID or not, or maybe I can do like this way where P underscore ID equal to 3 or not. Okay, so this is our hard coded value. Like that, for this row, what we have to do, suppose if ID is 4, we have to check whether PID equal to 4, how many count value is there. Okay, that is the step 1. Then for creating correlated subquery, what I have told you, what is the step 2? Step 2 is frame the overall query or outer query. Okay, so how our outer query will look like? So outer query will look like this. Select id comma p underscore id comma count value from tree. Okay, so this count value will basically contain the total count, that how many times one particular id is present in PID column. Okay, and here we need to define that now. Okay, so I will just put alias, and this particular code I'll be taking from here and I will simply paste it here. Okay, now here what we did earlier, same thing we'll be doing. Outer query tree name I'll be giving A, inner query tree name I'll be giving B. Okay, now this PID, from where we are taking this PID, we are taking from B table, right? So where b dot PID equal to 4. So now instead of 4 we have to put dynamic value. So this 4 is coming from here. Where? 4 is coming from the outer query. So I'll be writing a dot id. Okay, so each time while iterating, a dot id value will be coming here, and then it will be checking whether that particular id is present in the particular parent id column for our B table or not. That is, for each row of A table, the inner query will be executed one time. Okay, now once we get that, what we can do, I can delete this upper part, and then here I can do select. So here we need id and then comma, we have to basically detect whether that is leaf node or root node or inner node, right? So we can use a case statement. So case when count value equal to 0. So if count value is 0 means what? Count value 0 means the id is not there in parent id column. That means that id is not acting like parent. Okay, that means that is leaf. So when count value equal to 0, then what we will do, we will define that as leaf. Okay, we'll just copy that and paste it here, then leaf. Okay, and then the next when condition will be what? Then if else kind of condition. If count value is non-zero, okay, then what might happen? If count value is non-zero, that means that particular id is present in parent id column. That means that id is treating like parent. So what kind of nodes can act like parent? Either that can be root or that can be inner node. So we have to check one more condition where count value not equal to 0. That means that id is acting like parent. And for that particular id, if the parent id column is null, okay, for that particular id, if the parent id is null, then it is nothing but root, correct? And if count value is non-zero, that means that id is acting like parent, but parent id is not null, that means that is acting like inner node. Very simple, right? And then here we will end this. Okay, maybe I will put a from clause and I can put this whole stuff inside the query, so that this one is acting like whole subquery, and maybe I can give the alias name as C. Okay, so now what we have to do, we are getting the id and then it is getting detected whether it is leaf node or root node or inner node. Okay, how it is asking the output that way. Only thing is here the column name is type. So here what I will do, I'll be giving the alias name as type. Okay, let's run the code. So it is accepted and let's submit it. Okay, let's see whether it is working or not, passing all the test cases or not. No, it has not passed all the test cases. Okay, which test case it is failing? So if input is looking like this, then our output is not matching. So input is id and only one. Okay, so if only one node is there, so if you check our example 2, only one node is there, that time our this code is failing. Let's see how it is giving the output. I will just paste the same and let me submit that. Sorry, instead of submit I could run the code. So I will just run the code and I will see what our code is giving output. Okay, so here if only one single node is there, then our output is detecting that as leaf node. Okay, but expectation is root node. Okay, so why our code is detecting if only one node is there, then why our code is detecting that as leaf node? Because if you see this particular table, then here this particular id is not present in parent id column and the first condition is satisfied, then it is simply saying it is leaf node. Okay, so we have to update this condition little bit. So when count value is 0 and the parent id is null, is not null, okay, then only it is leaf node. And if suppose this kind of situation happens that count value is 0, that means that particular id, that particular node id is not present as a parent, that id is not acting like parent. But if the parent id is null, that means that is a root node. Like in our this particular case, this id 1 is not present in parent id column, but parent id is null, and that time it is acting like root node, right? So that one condition will be satisfied here. Okay, right? So let's run it now and let's see whether it is satisfying this exceptional test case or not. It is successful. Let's submit it and see it is successful, right? So with respect to memory, it is 100% optimized. Okay, but with respect to runtime or time complexity, it is 64.81%. Obviously we can improve with self join and some other simple approaches. Okay, but this time I just wanted to show you how we can apply that structured approach of framing the correlated subquery. Okay, that's why I just discussed this approach. I hope you enjoyed this. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you.